Sketching a curve. All right, so we're going to graph this guy. Where is he? He's right here. Okay, we're going to graph f of x, but we're going to use calculus instead of algebra. In algebra, you guys learn how to use a table, and you guys also learn how to pick, well, picking points is the same as using a table. You also learn how to use translations, or transformations, however you want to call it. But we're going to use calculus right now. And to use calculus, we're going to look at the first derivative test and the second derivative test. And the last thing I wrote here is the double sine line graph. That is just a combination of these two that we can use to finish the job. All right, the first derivative test tells us where the function is increasing or decreasing. The second derivative test tells us where the function is concaving up or concaving down. Okay, and so I'll show you guys how we use that, but first we got to find them. So first let's do the first derivative test. So to do the first derivative test, obviously we're going to need the first derivative. So I'm going to find f prime. Oh, and by the way, guys, I'm using a very simple equation right here, and it's mostly just for the sake of learning. There's more complicated equations out there, but if you guys are using the first derivative and second derivative test and you guys have no problem with taking derivatives, this shouldn't be a problem. And so what we do with the first derivative test is we first find the first derivative, and then we find out where the first derivative is either equal to 0 or undefined, so it does not exist. Now, because this is a linear equation, it is very clear that we're not going to have a does not exist, because there's no x value that we can plug into f prime to make it undefined. So when we solve this, we get x equals -5/2. When I'm graphing, I don't like improper fractions, so let's make that into a mixed number. That would be -2 1/2. So this is called a critical value. Critical values are x values that when you plug into f prime, you get 0 or does not exist. Critical values is where you might have possible extrema, like a maximum or minimum. We're going to use critical values to make our first sine line graph. Here's my first sine line graph for the first derivative test. I'm just going to put a -2 1/2 right here. And what we're going to do right here is we're going to find out in this interval right here if all of the f primes are positive or negative. And then we're also going to find out in this interval right here if all the f primes are positive and negative. And so in order to do that, you can pick numbers and plug them in and test them. And so on the left side of -2 1/2, I can plug in -3. On the right side, I can plug in -1 or -2, but I like to plug in 0 whenever I can. And since 0 is on the right side of -2 1/2, I can plug in 0. And so I'm going to plug those in. And I'm not even going to find the answer. Even though this is really easy to find the answer, all I need to know is if it's positive or negative. So if I plug in -3 to that, I'm going to get a negative number, and then I'm going to add 5 to it. So the question is, how negative is this number? Well, that would be -6. So -6 plus 5, that would give me a negative number. So we're definitely negative for the first interval. Let's get rid of that and put in negative. And then for the second interval, let's see if we're negative or positive. I'm going to plug in 0 to f prime, and I don't really want to write it, but I'm trying to be thorough for you guys. So f prime, plug in 0. If I plug in 0 to that, that would be a 0 plus 5, so we know we got a positive number, so we have positive. So we know that before -2 1/2, f is decreasing. Remember, we know it from it if we're decreasing or increasing. And then after -2 1/2, f is increasing. So that's what f is doing. Let's now do our second derivative test. To do our second derivative test, we're going to need the second derivative. And so to find the second derivative, I'm going to take the derivative of that. And I get f double prime equals 2. Now usually, since this is a super simple problem, we don't have to do this, but usually what we would do is we would take f double prime and we would set that equal to 0, just like we did right here with f prime. And what we're looking for this one would be possible inflection points. Possible inflection points. And the reason why they would be possible inflection points is because a point is not an inflection point unless the sign changes. You see how the sign changes right here for -2 1/2? The sign changes. But this is for f prime. If that were to happen for f double prime, if the sign changes, and we did a sine line graph for f double prime, then this right here would be an inflection point. But if the sign does not change, it would not be an inflection point. Okay, so that's true for f double prime. For f prime, these are always going to be critical values. It doesn't matter if the sign changes or not. they're always going to be critical values. Because f double prime equals 2, we're not going to take 2 and set it equal to 0 because that doesn't work. There's no possible inflection points that we can use to create our sine line graph. There's like what we did for f prime. Instead, on our sine line graph, we're always going to be positive because it's a positive 2. Never changes the sign of f double prime. So now what I'm going to do is I'm going to create my double sine line graph so I can create my graph. Now remember these sine line graphs right here, these are x-axes. Now this is going to be a double sine line graph, and what you're supposed to do when you get to a double sine line graph is you're supposed to take all the critical values, all the possible inflection points, and you put them on this sine line graph. But here we only have one. We only have -2 and 1/2. And so we put -2 and 1/2 right there. And then I like to do the dotted line, but you don't have to. I'm just trying to separate the different intervals. We only have this interval and this interval. Now to do a double sine line graph, we need to put the signs for f prime, the first derivative test, and the signs for the second derivative test. Now, for the second derivative test, it's always positive. So our second sign is always going to be positive. The first sign, however, changes. So the first sign is negative for the first interval, and then remember this for the second derivative test, we're always positive. So that's why that one's positive. And then for the second interval, f prime is positive, so I'm going to put positive, and then we're still positive for the f double prime. So here we have our double sine line graph. Now, when you're first curve sketching, it's kind of weird to have to think about concavity and think about increasing and decreasing at the same time. And so one thing that I like to show my students is I like to show them a little table to try to get them used to drawing the curves. Okay, so I guess you call this a curve table. So plus negative, minus positive, and then minus. This row would be the increasing curves, and this row would be the decreasing curves. This row right here would be the concave up, so I'm going to say concave up, and these would be the concave down curves. So concaving up and going up, it would look like this. Going down and concaving up, it would go like that. For the next one, going down, we're decreasing, concaving down. So we're decreasing and going down, concaving down. And this one's decreasing and then concaving, or sorry, first that one's wrong. This is increasing and concaving down. So we're going to have to go like this. And then this one's decreasing and concaving down. That one is the one that looks like this. Okay, see, all these curves are different. It's kind of weird. If you guys think about parabolas, like just a simple basic parabola, they have all the curves inside them. So if I drew like a line right here to separate intervals, this section right here would be decreasing and concaving up. This section right here would be increasing and concaving up. So this parabola right here is always concaving up. This parabola right here is always concaving down. This would be, let me draw a line right here. This would be decreasing and concaving down. I'm sorry, increasing. Man, I'm messing up. Increasing because we're going up right here. Increasing and concaving down, and then this one's going down. So that would be decreasing and concaving down. So there we have all our signs within two parabolas. And so if we have this, then we have an idea of what our sketch is going to look like. Now I have no points for this. I could plug in a point so I have a starting point, but I don't want to think about that right now. So let's not even put the y-axis. So all we need is the -2 and 1/2, and our curve is going to look like this. We're going to be decreasing and concaving up first, and then we're going to be increasing and concaving up for the second interval right there. So that's a curve sketch. Now remember, curve sketching, it doesn't matter what the y values are for f unless the problem that you're working on gives you those y values, or a y value, so that gives you one coordinate to work from.